Good morning, class. Today we're going to look at how truth tables can be constructed to prove that two Boolean expressions are equal. So we begin with this first example here. We want to prove that this expression on the left side will always produce an output of 0. So let's get started. The first thing to do is to note that we only have inputs A and B. And so this means that in our truth table, we require only 4 rows. And that's because we have 2 squared or 4 possible states. We use our pattern for A and our pattern for B to establish those 4 possibilities. Both off, B on, A on, both on, like this. And now we add columns as required. So looking at this left side, I can see that I would need an inverter after A and an inverter after B. So I might want to include those as my next columns here. So A0 would be the opposite of A, so it would be 1, 1, 0, 0. And B0 is the opposite of B, which means it will be 1, 0, 1, 0. Now, if I were drawing the left side, I would be making an AND gate here and an OR gate here. And so I need to include those columns here in my chart as well. So a multiplication column and an addition column like this. So how do I work out AB? Well, I simply multiply the numbers in column A with the numbers in column B like this. 0 times 0, 0 times 1, 1 times 0, and 1 times 1. And how do we form this column? We have to look at column A0 and column B0 and add those numbers. So 1 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 0 plus 0 is 0. Finally, in setting up this last side, there is the implied multiplication right here. This would correspond to one more AND gate. AB is multiplied by A0 plus B0. So I make sure I look at column AB and column A0 plus B0, and I multiply the numbers together. So 0 times 1, 0 times 1, 0 times 1, and 1 times 0. And you can see that we end up with all zeros. And that's actually what we wanted to prove in this first example. So regardless of what the input, the output is always 0. And that's it. If you wanted to, make this look a little bit nicer, we would include this, the vertical lines between the columns like that. Okay, so that's a truth table proof for the first example. Let's do this second one here and now. So again, we take a look and there is no letter C. So again, we will need only 4 columns for our truth table. We start with column A and column B. And now I'm going to continue to set up this left side. And in doing so, I might want to make a column for A times B next. Okay, since that's certainly present in that left side, again, it would correspond to an AND gate. So what would the entries be? we multiply these numbers, so 0, 0, 0, 1. Okay, this pair is also in that left side, but before I can do that AND gate, A must pass through an inverter. So we make a column for A inverted, and it would be 1, 1, 0, 0. Now that I have A inverted, I can make a column for A naught times B. So when establishing this column, I have to make sure I look at column A naught and column B. Those are the numbers I'm multiplying together, right? So 0 times 1, 1 times 1, 0 times 0, and 1 times 0. And that gives me 0, 1, 0, 0. Okay, so 0, 1, 0, 0, like that. Now, the left side is now the addition of 3 things. So that would be accomplished with 3 items going into one OR gate. And so it also means we can use one column for that addition in our truth table. So to form the entry here though, I have to make sure I look at 3 numbers at once. The numbers in column A, the numbers in column AB, and the numbers in column A not B. And remember, we're adding. So as long as we have at least one 1, the output will be a 1. So let's try that. It would be 0 plus 0 plus 0. Then 0 plus 0 plus 1. 1 plus 0 plus 0. And finally 1 plus 1 plus 0. So this is our output, and that corresponds to the left-hand side. Now, what were we trying to prove it equal to? We need to prove it's equal to A plus B, and we don't have that column yet. So we need to have a column for A plus B. And let's establish its output. So column A, column B, and we're adding. So adding 0 plus 0, 0 plus 1, 1 plus 0, and 1 plus 1. And we're all set. And look at this. The output for the left side equals the output for the right side. And therefore we know this expression is the same as this expression. This would be the simplified version of this expression. And that's it. So now, again, if you like, we can put in these nice little finishing touches here. And I will say that it doesn't matter the order you put the columns in, although you always want to start with A and B like this. But after that, the order of the columns doesn't matter. So you could have a different order. What matters is that you have the same number of rows, 4, the same number of columns, in this case 7, and that your final column for the left side equals your final column for the right side. Okay, let's look at example 3. So I'm going to go through 4 examples with you. Now, the most striking thing in example 3 is that we now have the letter C. And so what does that mean? It means certainly that we'll start with column A, column B, column C. But more than that, it means now we have 2 cubed or 8 rows in our table. So we have to include 8 possible input conditions. So we use our pattern for column A, and then our pattern for column B, and then our pattern for column C. And always use this very same setup. Okay, now all we need to do is set up this left side. And again, order doesn't matter. I might set up this column now. This is an AND gate with the 3 inputs. So I can accomplish that in one column. I just have to make sure I multiply all 3 columns together. So when I do that, so we're multiplying, look what's going to happen. 0, 0, 0, 0, 0, 0, 0, and 1. So we'll have 7 zeros for that triple product and then a 1. Okay, so now I'm going to work inside the bracket here. And I know I want to do this duo and this duo. But in order to accomplish that, I actually need a column labeled B0 and a column labeled C0. So I'll do those next. So B0 will be the opposite of B, which means 1, 1, 0, 0, 1, 1, 0, 0. And C0 will be the opposite of C. So we'll do 1, 0, 1, 0 all the way down. Okay, now that I have those, I can do these little pairs. So this AND gate, A times B0, and this AND gate, A times C0. So those will be my next 2 columns. So let's multiply A by B0. So here's A and here's B0, and we're multiplying these numbers together. So 0, 0, 0, 0, 1, 1, 0, 0. So we get 1s here in columns, in rows 5 and 6. Okay, now let's do A with C0. And again, multiply 0, 0, 0, 0, 1, 0, 1, 0. Okay, so we got a 1 here in column 5 and row 5 and a 1 here in row 7, like that. Okay, so now still working on that left side, I've got this pair and this pair, I should add them. And that would correspond to having an OR gate next, right? So I have to simply add these 2 columns, 0, 0, 0, 0, and then 1, 1, 1, 0. Like that. And lastly, I've got this and this, and I have to do the implied multiplication. And there's not much room here left to write down this whole expression. So I might turn my page in order to do that, or you could do left side, right? You could just write LS for left side. I'll turn the page and then I'll put it back. But don't worry if this is off your screen right now. I'll make sure I adjust that before continuing. Okay. Let me line that up for us again. Okay, so this is the left side expression now, and I'm going to write its output here. And to work it out, I have to be multiplying column ABC, which is here, by this column, which is the last one we did. Okay, multiplication is implied right here. That's what the bracket means. So here we go. We're looking at these numbers and we're multiplying. Well, we can look at all these zeros. So we know for sure we've got zeros all the way down. The only one to check is here, but it's 1 times 0, so that's also 0. So what do we end up with? 8 of these goose eggs. And that is our final column for the left side. And that's what we were trying to prove, was that no matter what the input was for this circuit, the output would be 0. Okay, so that is done. You needed 8 rows because we had 3 inputs, A, B, and C. And each of those inputs could be either a 0 or a 1. And so that corresponds to these 8 possibilities here. Okay, so that is now complete for number 3. And in order to get full marks on a problem like this, you have to make sure you have all of these columns present. So 3, 6, 9, 10. You have to have 10 columns, so don't be skipping a column like B naught or a column like C naught. You have to show all 10. That would be worth 10 marks. Okay, we're gonna do one last example here, number 4. So again, I can see the letter C is also present. So I'm gonna set this up with my 8 possible states. So the pattern for A, then the pattern for B, and then the pattern for C. And don't change your patterns ever, okay? Because remember I showed you this is the same as counting. This would be counting 0, 1, 2, 3, 4, 5, 6, 7, okay? So now we're gonna work on the left side. And here's something I'd like to point out. Look at this pair here, BC. It's here, and it's here. But you only would make that once in your chart. Why don't we plan this one out and see how many columns we're gonna need, okay? So I've got A, B, and C done already. That's nice. Let's see what other columns we will need. So we'll need a column for AB. Okay, so I'm gonna put that column next. We're gonna need a column for BC. Only once though, even though it shows up 3 times, we only need to have that once. What else do we need? We're gonna need an AC, so maybe I'll get that pair out of the way as well. So now I've got all the pairs. So those were the 3 AND gates. Now this is an OR gate and this is an OR gate. So I need a column for that OR gate and a column for this OR gate. And then what else? In setting up the left side, I've got this and this done, this and this. What's the last thing to do? Multiply those together. So the final column we need will be the multiplication, which would correspond to one more AND gate. So we're multiplying this by this. And again, that's what's implied when you see those brackets like that. So we need all of that just to set up the left side of the equation. So we're gonna get our answer right here for the left side. And what are we trying to prove it equal to? To BC. And that is back here. So when we're done, we're hoping the entries here will match the entries there. Okay, let's fill in our zeros and ones. So multiply A and B. 0, 0, 0, 0, 0, 0, 1, 1. Okay, so we get ones at the bottom. Multiply B by C. So these two, right? 0, 0, 0, 1, 0, 0, 0, 1. Multiply A and C. 0, 0, 0, 0, 0, 1, 0, 1. Okay, so that was multiplying A by C. We got a 1 here. That would be row 6, and a 1 here, row 8. Okay, I've got the AND gates done. Now I'm going to do OR. So these two here, AB plus BC, right? It was this expression. So adding AB plus BC, adding. So as long as we have a 1, at least 1, 1, we will get a 1. So 0, 0, 0, 1, 0, 0, 1, 1. Oops, let me try that again. 0, 0, 0, 1, yes. And then 0, 0, 1, 1. Okay. AC plus BC. That's these two. And again, as long as we have 1, 1, we will write down 1 as the output. 0, 0, 0, 1, 0, 1, 0, 1. Okay, so we got a 1. This is for this bracket here, AC plus BC. So we got a 1 here in row 4, and again in row 6, and again in row 8. All right, and to finish the left side, we need the multiplication between the two brackets, the implied multiplication. So here I go. That means multiplying the numbers in these columns. Multiplying. So 0, 0, 0, 1. 0, 0, 0, 1. And I'm finished. And now I can check. That's the expression for the left side. BC, which is back here, is the expression for the right side. Oh, they match. I'm so happy. Okay, and then we're all set. So I hope you enjoyed that lesson on establishing proofs with truth tables. I've got some suggested problems for you to try in the very same way. So please check Blackboard for that reference. Okay, thanks and have a good day.